polynomials. So usually in mathematics, in each and every concept, in each and every chapter, we need to discuss fundamental operations on the newly developed theory. Here polynomials. So polynomials, as we discussed in the last class, polynomials are a special types of algebraic expressions. Okay, what is that speciality? The power should be non-negative integral powers. Then an algebraic expression with non-negative integral powers are usually considered as polynomials, and polynomials are simply nothing but algebraic expressions only, and that's why applying fundamental operations on polynomials is simply nothing but just like of algebraic expression. Okay, addition, subtraction, multiplication of polynomials is just like of algebraic expressions. I think you are very familiar with adding two algebraic expressions, subtracting as well as multiplying with algebraic expressions, very clear. Since you are all clear with those things, I am not discussing here, okay? Right. So you just recall that the fundamental operations on algebraic expressions is just like happens in polynomials, that's it. But here we need to concentrate something much more on division of polynomials, okay? Usually division of algebraic expressions, actually we won't discuss at algebraic expressions, so that we need to concentrate on what? Division of polynomials. Basically what is division? Okay, division of polynomials. For suppose if you have something like 3x power 4 y divided by x square. So dividing a monomial with monomial, or you say a polynomial of one term with a polynomial of other term, it is bit easy. So you just divide x square and it is directly 3x square y. I think you all know the way of division also. Whereas if you have some like x square y plus xy square divided by xy, dividing two terms with one term, then it is you just split it, you just separate it. How can it becomes x square y by xy plus xy square divided by xy, and it is also a bit easy, which is simply x and this is y. Okay, but dividing a polynomial with polynomial, in the sense polynomial having more terms in numerator, polynomial having more terms in the denominator. So for those type of divisions we need to discuss. Okay, something like x cube minus 3x square plus 4 divided by, you may say, x square plus 1. Just have it. See, we are going to divide this x cube minus 3x square plus 4 with x square plus 1. So what we do? You just consider this, what, x cube minus 3x square plus 4, and you just divide it with x square plus 1. So how to divide? Just recall previous knowledge of algebraic expressions. I think you know something about the way of dividing. See, first of all, this first term is x cube. Okay, this first term is x cube, this first term is x square. So you just divide that first term with this first term. X cube divided by x square is x. Write that x in the quotient part. So now after writing x, you just multiply. So x into x square is x cube plus x into 1 is x. That's it. And then you do subtraction, minus minus. So x cube and x cube will get cancelled, and then you need to write the remaining terms here. So in an order I am going to write minus 3x square is the x square term, minus x plus 4. Okay. So one step of division is clear. Then coming to the next step, here again what is the first term? The first term of this dividend part is minus 3x square, and of this is x square. Divide this minus 3x square with this x square. When you divide this first term minus 3x square with this first term x square, you left with what? Minus 3. So write that minus 3 in the quotient part. And after writing that, you just multiply this minus 3 with this divisor. So minus 3 into this x square is minus 3x square. Minus 3 into 1 is minus 3. Okay, that's it. Then again do subtraction. While subtracting, you just change the symbols. These two will get cancelled. You left with minus x plus 7. Okay, minus x plus 7. And now when you observe, is there any possibility to go for the further steps? See, when you observe here, minus x is the first term, x square is here the first term. When you divide this first term, minus x, with this first term, x square, you will get minus 1 by x. But this type of minus 1 by x, see, actually after dividing this first term with that first term, you need to write this value in the quotient. But this type of minus 1 by x terms are not involved in polynomials. We won't allow, see, this type of 1 by x square type of terms in polynomials, and that's why you need to stop the process of division at this stage. Okay? And actually, you know, different names, we usually what we call these parts of division. From number system itself, you know that it is dividend, and this is divider, this is quotient, whereas this is remainder. At the end for this division, this is the divisor. I will conclude once again, okay? And before going to conclude, once again you just follow the way of division. See, we need to divide this x cube minus 3x square plus 4 with this x square plus 1. So you just write that x cube minus 3x square plus 4 here, divide with this x square plus 1. So as a part of division, you just think about this first term x cube and this first term x square. Divide this x cube with x square, you will get x. Write that x here. And then multiply x into x square is x cube, x into 1 is x. Do subtraction. These two will get cancelled. So list the remaining terms. Minus 3x square minus x plus 4. So for the second step of division, see, think about this first term minus 3x square and this first term again x square. So this first term divided by that first term is minus 3 right here. So, and then after writing this, minus 3 into x square is minus 3x square, minus 3 into 1 is minus 3. So continue. Do subtraction. While subtracting, we need to change the symbols, like this minus will become plus and this minus will become again plus. These two will get cancelled, and here minus x plus 7. So we need to stop the process of division at this stage, because polynomials don't allow us to continue further. Why? Because if we continue with the same procedure by concentrating on this first term and that first term, you may get these type of terms in the quotient, but these are not allowed in polynomials. So you just stop the process of division at this stage and you just call this minus x plus 7 as remainder. I will give you the names and then further steps after this. I will conclude after this. Just have a look first. So addition, subtraction and multiplication is just as like in algebraic expressions, but whereas division you need to recall once again, and then like this we need to go. Have a look. So this is division of polynomials, and from number system itself we know the names of all these parts of division. Usually what we call dividend. Okay, we will divide dividend with divisor, and this part is usually considered as quotient, whereas we left with remainder. So these names are very familiar for all of us. So and now we call these, since we are doing division in polynomials, we call this as dividend polynomial, and this is divisor polynomial, and this is quotient polynomial, whereas this is remainder polynomial. Is it right? Or simply you may say remainder or quotient, no problem. So when you compare these names with the polynomial, you will get that for this particular problem, for this particular example, dividend polynomial is equals to x cube minus 3x square plus 4, whereas divisor polynomial is what? X square plus 1, and quotient polynomial as x minus 3, whereas remainder polynomial is here what? Minus x plus 7, right? And after that, see, if you have this division, dividend is equals to divisor. See, dividend, divisor, quotient and remainder. If you have all these things, then we have a division algorithm of numbers. In numbers we have what? Division algorithm. See, what is the division algorithm of numbers? See, in numbers itself, division algorithm is simply dividend is equals to divisor into quotient plus remainder. The same thing we can extend it for polynomials also. See, from numbers we are very clear with this division and these names and the division algorithm. So, what is the division algorithm here? So, for numbers, division algorithm is simply what? Dividend is equals to divisor into quotient plus remainder. We know in numbers itself, okay? But now we are going to extend this idea for polynomials, okay? See, for polynomials also this statement is clear, is possible. So to check, you just go with this example. We have dividend polynomial, divisor polynomial, quotient polynomial and remainder polynomial. You just multiply this divisor polynomial with quotient polynomial and then add remainder polynomial, you will get surely dividend polynomial. Okay, so for that checking, I will use this space. I will erase it. I think this division is very clear. Okay, I am erasing this. Yeah. Now you just check it. We are going to checking. Yeah, we are going to establishing division algorithm for polynomials. Okay, to establish division algorithm of polynomials. To establish division algorithm of polynomials, we are just moving with an example. See, you just multiply, yeah, divisor polynomial into quotient polynomial plus remainder polynomial. So that is equals to divisor is what? X square plus 1. Quotient is what? X minus 3. Plus remainder is what? Minus x plus 7. We need to multiply and then we need to check whether it is equals to divisor or not. See the way of multiplication. X square into x, x square into minus 3, 1 into x, 1 into minus 3. You just list it and then add that minus x plus 7. Okay. So how it becomes? X square into x is x cube minus 3x square, 1 into x, 1 into 3 minus x plus 7. And that is equals to x cube minus 4x square, minus 3x square, right? Minus 3x square, this x and that x will get cancelled, plus 7 minus 3 is 4. So x cube minus 3x square plus 4 is simply nothing but what? Dividend polynomial. So at the end what we conclude? For polynomials also, this divisor polynomial into quotient polynomial plus remainder is equals to dividend polynomial. This is possible. And now in the next bit D, we are going to give a statement for the division algorithm of polynomials. First of all, have a look. So from this example, we are very clear about the division algorithm of polynomials, just like in numbers. Okay. See, just look here, division algorithm of polynomials. Okay, so very important statement. Okay, this division algorithm of polynomials is simply dividend polynomial into divisor polynomial into quotient polynomial plus remainder polynomial. Just like this, divisor into quotient plus remainder is equals to dividend. But you need to conclude that what is this remainder? That remainder should be the degree of the remainder is always less than degree of divisor. Usually in numbers what we say? In number system, division algorithm is remainder is less than divisor. Remainder value is less than divisor. Here instead of that value, we need to think about the degree. So degree of remainder polynomial is less than degree of divisor. Then in that case we need to stop the division process and that last part of dividend is considered as the remainder. Here if you think this minus x plus 7 is a polynomial of degree 1, whereas this divisor is a polynomial of degree 2. Clearly the degree of remainder is less than degree of divisor. So for all types of polynomials and divisions this will happen, and at this position we state it as division algorithm of polynomials. in this division algorithm of polynomials, see, the thing which is very useful and very bit complicated is this particular one. Degree of remainder is less than degree of divisor. Okay, right. So, for suppose if you treat the polynomials as some f of x and g of x. So, for any two polynomials, okay, for any two polynomials, f of x and g of x, take any two polynomials f of x and g of x, there exist q of x and r of x, there exist q of x and r of x such that you just take any two polynomials f of x and g of x, for sure there exist two polynomials q of x and r of x such that f of x is equals to g of x into q of x plus r of x. Okay, see, if you treat that f of x as dividend, g of x as divisor, and the newly formed, the newly arrived, okay, derived q of x and r of x are quotient and remainder, so this statement will happen, and where you need to conclude, where you need to confirm that the degree of the remainder polynomial r of x is less than degree of g of x, or sometimes the r of x may be directly equals to 0. See, if remainder is 0, then its degree is actually not defined, and that's why we need to give this particular thing separately. Okay, so you just observe it. This statement usually we use as a statement of division algorithm. F of x is equals to g of x into q of x plus r of x, where degree of r of x is less than degree of g of x. See, we may write it like this. We are dividing f of x with g of x, and we will get q of x as quotient by leaving r of x as remainder. See, for this division, this is the statement of division algorithm. Both will convey the same message, but this is in words, and this is using the polynomials f of x, g of x, q of x, and r of x. Just have a look. So, as we discussed, this is the division algorithm, and from there always we are mentioning that degree of remainder is less than degree of g of x. That in the sense, the degree of this divisor g of x, see, will give you a general form for the remainder. So always this remainder is dependent on g of x. In generally, remainder degree is dependent on degree of g of x. Okay, and that's why, see, I will give you some notations which are very helpful in solving the problems. Just have a look. Degree of divisor g of x. For suppose if this degree of g of x is 1, what will happen? See, if degree of g of x is 1, you just think about the remainder. See, as they said, degree of remainder is less than degree of divisor g of x. See, this is 1, so degree of r of x is less than 1. So less than 1 in the sense it may be 0, right? Okay, so degree of r of x is 0. So degree of a polynomial r of x is 0, then it will happen only if that r of x is a constant. So the general form of the remainder r of x is just simply a constant k. You will take a constant k. Why? Because its degree is 0, because it is 1. Okay, and for suppose if degree of this divisor g of x is 2, what will happen? Since degree of divisor g of x is 2, so this is 2. Since this is 2, degree of r of x is less than 2. Degree of r of x is less than 2 in the sense, what is the degree of r of x? Less than 2. That means it may be 1 or it may be 0. So you need to give a general form which convey both the possibilities. So here my choice is ax plus b. Why I am taking this ax plus b? See, I don't know that r of x, but I know the degree of r of x is either 1 or 0. Okay, see, if these constants a, b, if these constants both a and b are non-zero, then this is what? Linear, degree 1, okay, degree 1 possibility. If for suppose if the value of a is 0, then you left with b, that represents that degree is 0. So we have two possibilities. The degree of the remainder may be 1 or may be 0. So when you give this as the general form, depending on the values of a and b, sometimes the degree of r of x is 1 and sometimes the degree of r of x is 0. It depends on a and b, and according to the problem we need to find those values in. Okay. And now if the degree of divisor g of x is 3, degree of g of x is 3, degree of r of x is less than 3, that means that r of x may be of degree 2, may be of degree 1, may be of degree 0. So we need to give a general form which convey all the three possibilities, and my choice of general form is ax square plus bx plus c. Okay, these values a, b, c are variant depending on the problem. Okay, if a is non-zero, so r of x is of degree 2 directly. For suppose if a is 0, then this is a degree of 1, and if b also 0, then it may be a constant. It is a constant and the degree is 0. So possibilities of degrees having 0 or 1 or 2, everything is conveyed with this form. Okay, and the same way if I extend, if the degree of divisor is 4, then the general form of the remainder is what? Ax cube plus bx square plus cx plus d. Likewise we will extend this idea, and this idea is very helpful in solving many problems. Okay, have a look. If the remainder r of x is equals to 0, then how the division will become? See, here the remainder is 0, and that's why we say that this g of x is a factor of f of x. If the remainder is 0, then we say g of x is a factor of r of x. No, factor of f of x. Since g of x is a factor of f of x, in this situation, since remainder is 0, we directly write that f of x is equals to some g of x into q of x. There is no remainder because the remainder is 0, right? So f of x is equals to g of x into q of x. Okay. So here not only g of x, we call that q of x is also a factor. So this will convey you this. See, it's an if and only if condition. Since if remainder of x, if remainder is 0, then g of x is a factor of f of x. For suppose if g of x is a factor of f of x, then what will happen? Then remainder is 0. Okay, it's an if and only if condition. If it will happen, you will confirm that g of x is factor. If g of x is factor, then then we are confirmed that the remainder is 0. Is it clear? For suppose what I say, yeah, I need to give you like that, x minus r something. Okay, you just take it. X square plus 7x plus 8 is a factor. Is a factor of f of x. See, x square plus 7x plus 8 is a factor of f of x. Since this quadratic is a factor of f of x, what it means? When you divide that f of x with this x square plus 7x plus 8, you left with a remainder 0. Because we said it like that. Since it is a factor, that remainder is 0. And since that remainder is 0, we have a chance to express this f of x like this. So from this division we will conclude that f of x is equals to x square plus 7x plus 8 into some q of x. X square plus 7x plus 8 into some q of x. Okay. So if remainder is 0, we call that g of x as a factor, and if g of x is a factor, then for sure you will get remainder 0, and in that situation we will write that f of x as g of x into q of x. Right? Have a